All right, today's lesson is going to be factoring, but this time we're going to specifically focus on grouping and then some combinations. In our last lesson, we talked about some methods of factoring, which were the first one was always to look for the greatest common factor. Then our second was to look for a difference of squares, which has a minus sign, a binomial, and perfect squares. And then we talked about trinomial factoring. Well, today we're going to use those, but build on them and learn some new techniques as well. So if I take a look at my first problem, it's a four-termed polynomial. So I can't do a trinomial factoring or a difference of squares. Those are out. I still always want to try a GCF first. Look for a greatest common factor. Well, I don't have a greatest common factor. So when you have four terms, one method we're going to teach you is factoring by grouping, meaning we're going to group the first two terms and the second two terms today. So today we're going to do 2-2 grouping. There are other methods of grouping as well that we will teach you later. 2-2 grouping is taking the first two terms, grouping them, taking the second two terms, grouping them, and see if they have something in common that I can pull out. So if you look at the first two terms, x cubed plus 3x squared, I can pull out an x squared because that's common to both. If I see what's left over from those two terms, x cubed divided by x squared is x, and then 3x squared divided by x squared is positive 3. You need to make sure that when I re-multiply back out, like x squared times x is x cubed, x squared times 3 is 3x squared, I get what I started with, right? So I just did a GCF the first two terms. Now I want you to kind of ignore those two terms, and let's look at the next two terms. What is the GCF here? Well, out of 4x plus 12, I can pull out a positive 4. So when I pull out a positive 4, let's see what's left over. 4x divided by 4 is x. 12 divided by 4 is 3. What's great about 2-2 grouping is if you've done the problem correctly, this binomial will be the same and it will be written twice. So what we're going to do is I'm going to pull out the common factor of x plus 3, and then what's left over, or what's on the outside, is going to be my other binomial. So I have x plus 3, parentheses, x squared plus 4, parentheses, and that will be my final answer to factor that four-term polynomial by grouping. Let's look at number 2. Again, I don't have a trinomial or a binomial, and I can't pull out a greatest common factor. So let's try our method of 2-2 grouping. Pull out what's common to 3x squared and 6x cubed. So I can pull out, let's see, a 3x squared out of both of those terms. So 6 divided by 3 is 2. X cubed divided by x squared. Again, division means subtraction of exponents. If I had 3 and pulled out 2, I have 1 left over. Now, this 3x squared and 3x squared, a lot of you guys just want to leave your parentheses like this. But if I distribute through, you're only getting 6x cubed. You're not taking care of the 3x squared. 3x squared divided by 3x squared is just 1. And you need to keep that placeholder in there or else it would not multiply back to what you started with. Let's go ahead to the second two terms. Now, in the back of my mind, I want to know that this is going to be 2x plus 1 is the binomial that I want to get. So if I look what I have, well, I kind of already have it, but I still do need to pull out a common factor. And even though I don't think about it very often, if we pull out a positive 1 and divide through, I would get 2x plus 1, which would make this binomial and this binomial the same. So what I'm technically doing is I've got one term here and another term here. And what I'm looking to do is I'm looking to pull out 2x plus 1 as the greatest common factor. Meaning if I pull out 2x plus 1 from this term, if I pull that out, okay, I would be left with 3x squared. And if I look at my second term, if I took and pulled that out and divided that out, I'd be left with plus 1. So that's how the numbers out front are one of your binomials, and whatever's doubled is your other binomial, because truly you're pulling out a greatest common factor. Okay, let's look at number 3. Same thing, 4 terms. Let's go ahead and try our 2-2 grouping. Out of the first two terms, I can't pull out a coefficient, but I can pull out an x squared. So when I pull out x squared, I'd be left with 5x plus 4. Let's look at the second two terms. I can't pull out a variable, but it looks like I could pull out, now I want a 5x plus 4. I want the 5 to be positive. So knowing that in the back of my mind, I know I'm going to have to pull out a negative 2. Because if I pull out a negative 2, negative 10 divided by negative 2 would be positive 5. And then negative 8 divided by negative 2 is positive 4. And that's going to get my binomials to match up, which is going to make me happy because I know I factored this by grouping correctly. So 5x plus 4 is one of my factors. The numbers on the outside are my other factor. Now I want to look to these to factor again, but neither of these will factor again. This is a difference, but 2 is not a perfect square, so I'm done. All right, same concept in number 4. Why don't you guys try 4 and 5 on your own, and then come back and check your solutions. Try to use 2-2 grouping, and again, see if there's anything that you can factor further. Okay, number 4, if you paused your video and did this yourself, factor 2, 2. I'm going to pull out a 4x squared and be left with 3x plus 1. And again, knowing it's a positive 3x plus 1, I'm going to pull out a negative 9 so I can get 3x plus 1. So one of my terms is 4x squared minus 9. The other term is 3x plus 1. And it doesn't matter what order you put those in. If you put the 3x plus 1 first, 4x squared minus 9 second, doesn't matter as long as you include them both. However, if you looked closely, this is going to be a difference of squares. So I can factor that binomial again, 2x plus 3 and 2x minus 3. But don't forget to bring down what you couldn't factor again. Okay, just bring it down as it is. So that would be my final answer for 4. So not only did I do 2, 2 grouping, but then I wound up doing a difference of squares to simplify it so it's factored completely. Now let's look at number 5. Again, if you did this on your own, let's try 2, 2 grouping. You should have pulled out an x squared, and you get 2x plus 3. Now, again, I have a negative 2x minus 3. If I want to get a positive 2x plus 3, I've got to pull out a negative 1. So put negative 1 here. Negative 2 divided by negative 1 is positive 2, and I still have an x. Negative 3 divided by 1 is positive 3. So I know I've done this correctly because 2x plus 3 is my common factor for both terms, and then x squared minus 1 is what's on the outside. Again, be careful to factor completely. So this is a difference of squares. I'm going to leave 2x plus 3, and then I'm going to factor x squared minus 1 into x plus 1, x minus 1. All right, lastly, number 6. It's a 4-termed polynomial. I'm going to look to do my 2, 2 grouping. The only difference is I don't have any numbers, but you can still do the same concept even if you have all variables. If you look at the first 2 terms, what's common to them both is a b. So let's pull out a b, and we'll be left with x plus y. Look at the second 2 terms, they both have a c, so let's pull out a positive c, and I'm left with x plus y. And this follows the format of my grouping because x plus y is in both terms. So I'm going to pull that out. So if I pulled that out, I'd be left with a b in the first term and then a c in the second term. Look to factor those again, but as you can see, they won't factor anymore, so you're done. All right, part B is going to be combinations of problems, meaning techniques that we've used, but they're going to be a little bit more difficult. So we're applying the knowledge we've done before with factoring, but with harder problems. So example number 1, this looks very similar to a trinomial factoring that we've done before. The difference is now I have x to the 4th instead of x squared, and I have x squared as my middle term instead of x. So the way I want you to look at those, if you see an x to the 4th, an x squared, and then a constant, I want you to treat this just like a trinomial factoring, meaning we're going to say what 2 numbers multiply to give me negative 10 and add to give me negative 3. What 2 numbers multiply to give me negative 10 and at the same time add to give me negative 3. My numbers would be what, 5 and 2, and I would have to have a negative 5 and a positive 2. But the difference is if I just put x and x like I've done before, x times x would get me x squared, and that's not what the problem asks. They're saying, hey, x to the 4th is your first term. So if I throw in x squared times x squared, that will not only get me x to the 4th, but it will make my inner terms, okay, the negative 5x squared and the 2x squared, x squared the way I want it. All right, so it's very similar to the trinomial factoring, except we have x squared and x squared. Again, look to factor these, but because this is a sum, I definitely can't factor it. This is a difference, but 5 is not a perfect square, so I'm done. All right, same concept on number 2. What 2 numbers, since it is a trinomial, what 2 numbers multiply to give me negative 27 and add to give me negative 6? So what 2 numbers satisfy the conditions of multiplying to give me negative 27 and adding to give me negative 6? Well, negative 9 and positive 3 will multiply to give me negative 27 and add to give me negative 6. But I'm going to put an x squared and an x squared. And if you look at this problem, x squared minus 9 is a difference of squares. So I can factor that guy again, x plus 3x minus 3. I can't factor x squared plus 3, so just leave that alone, and I've factored that completely. All right, number 3, that's not a trinomial, so I'm not going to be doing that. Right now, it's not a difference of squares. What I always want to do first is my greatest common factor, and if you look carefully, they both share an x. So let's pull out an x. If I had 5 and pull one out, I have 4 left over. And remember, x divided by x is going to be 1. It doesn't go away. So negative x divided by x is negative 1. You want to continue to look to factor, and x to the 4th minus 1 will factor again. It's going to be a difference of squares. The only difference between this and probably ones we did last night was I have an x to the 4th. So the square root of x to the 4th is x squared, because when I multiply exponents, I actually add them. So 2 plus 2 gives me 4, and I'm going to make one of these a plus 1 and a minus 1. If you look even more closely, this problem is going to factor one more time because x squared minus 1 is a difference of squares. So I'm going to bring down the x, bring down x squared plus 1 because that's a sum of squares. I can never factor a sum of squares. And if I can squeeze this in, I would get x plus 1, x minus 1. All right, so that would be your final answer because it's factored completely. All right, number 4 is going to be similar to 1 and 2 in the sense that it's a trinomial. I can't pull out a GCF, but because it's a trinomial with a number out front, I need to do my guess and check methods. So I'm going to say, okay, how do I get 2x to the fourth? Let me try 2x squared and 2x squared. And to get 3, I know I'm going to do 3 times 1. Now this could not be the right answer. I don't know. I'm guessing and checking by FOIL to see if it works. So let's kind of work it out. It'd be 4x squared, and then I'd have a 2x squared and a 6x squared. Well, 2x squared and 6x squared, I can't work those in any fashion to get me a negative 11x squared. So 2x squared and 2x squared is not going to be what I want. I'm going to leave the 1 and the 3 because the only way to get negative 3 is going to be 3 times 1. But instead of 2x squared and 2x squared, the other factors of 4 that will work, let's try like 4x squared and 1x squared and see if that works. So that would be 4x squared plus 4 plus 3. Well, either way, if I make them negative or positive, that's not going to get me 11. So the only other change I can make was instead of having the 3 here and the 1 here, let's go ahead and switch those guys. So let's put the 1 here and the 3 here, and let's FOIL it back out. 4x squared, that would be 12 and 1. Well, 12 and 1 can definitely get me 11. If I want negative 11, I want my 12 to be negative, and I want my 1 to be positive. So I have 4x squared plus 1 and x squared minus 3. And that's it. I can't factor this. This is a sum of squares, and this is a difference, but 3 is not a perfect square. All right, number 5. This is an example that always trips you guys up, and I want you to look carefully so you don't make this much harder than it is. You have 1, 2, 3 terms here. All right, and if you look even more closely, you have a common factor of y plus 1 in all of those terms. So what I'm going to want to do is I'm going to pull out the y plus 1, because if I pull that out, it's going to go away, meaning I'm going to pull that out similarly to what I pulled out my factors in the 2 factoring. So let me show you what I mean. I'm going to pull out this y plus 1, and what I mean when I pull it out is I have 3 terms. So if I go back and look at this and I say, okay, I'm pulling out y plus 1 from the first term. If I do that, this would go away and I'd be left with y squared. If I go to my second term and I pull out the x plus y to that term, I'd be left with 7y. And if I pull out the y plus 1 with the last term, I'm left with positive 6. Now, some people get confused. They want to pull out 3 of these. I don't want to pull out 3 I want to pull out 1. But if you look to distribute, okay, y plus 1 times this, y plus 1 times this term, and y times plus 1 times this term is going to get me what I started with. So this truly is the correct way of factoring this. I'm going to pull out the y plus 1, see what's left over, but now I've got to try to factor again. Y plus 1 can't factor, but this is what multiplies to give me 6 and adds to give me 7. That would be a positive 6 and a positive 1. Oh, sorry, I should make a y there, not an x. So it would be y plus 6 and y plus 1. Now, the best way of writing that, since I have y plus 1 and 2 of them, is let's write this as y plus 1 quantity squared next to y plus 6. And that'd be it. Okay, flip over your page. I'm going to scroll down. Let's look at number 6. So 6 is just like number 5. It looks crazy. There's a ton of terms. It looks like it's going to be awful. Do not distribute this. Okay, that will make your life miserable. What I want to do is I just want to take out the common factor that these 3 things have in common. So they all have a y squared minus 100. If I pull that out of the first term, I'm left with y to the 4th. If I pull it out of the second term, I have negative y squared. And if I pull it out of the third term, I have minus 72. So I'm pulling y squared minus 100 out of the first term, second term, and third term and seeing what's left over. Now I'm going to continue to factor as best that I can. So I'm going to say, okay, this is y plus 10, y minus 10, because that's a difference of squares. And then let's try to factor this similar to what we did like problems 1 and 2 in part B. I want to say what multiplies to give me negative 72 and adds to give me negative 1. Because I have a coefficient of 1, I can do the multiply add method. Now 9 and 8 give me 72. If I make it a negative 9 and a positive 8, that would give me a negative 1. So that will work. But again, I don't need a y and a y. I need y squared and y squared because my problem asks for y to the 4th. So you've got to be careful. When you have things that are, y to the fourth, after you factor them, you got to continue to look to factor because this will factor again, right? Y squared minus 9 is a difference of perfect squares. So I'm going to write down y plus 10, y minus 10. I'm going to factor y squared minus 9 to y plus 3, y minus 3. And then I'm going to bring down the y squared plus 8. And that'd be my final answer. Now, number 7, it's not a difference of squares the way it is. What I need to do is I need to pull out a GCF. And if I pull out a GCF of 8, I'm going to be left with x cubed minus 8. However, I think we're doing cubic factoring in the next lesson. So we're going to go ahead and hold on this problem, and we'll come back to it because we are going to be able to factor the sum and difference of cubes. So we'll come back to this problem. But regardless, make sure you always pull out the 8 first, and then we're going to teach you how to factor that x cubed minus 8 in the next lesson. So let's jump to number 8. First technique is always GCF. So what do they both share? Well, I have x to the 6th and x to the 10th, so they both share 6 x's. If I divide out, I'm going to get x to the 6th divided by x to the 6th is 1. Okay? Minus x to the 10th divided by x to the 6th is minus x to the 4th. So let's look to factor this again. This is a difference of perfect squares. Don't forget to bring down your x to the 6th. The square root of 1 is 1. Square root of x to the 4th is x squared. Make one a plus and one a minus in any order. But I still have another difference of squares. This is a difference of squares. So let's go ahead and factor that to 1 plus x and 1 minus x, and then leave the 1 plus x squared. All right, number 9 is similar to 8, except I have 2 variables. So I can't pull out an x or y because they don't share anything. What I'm going to do, and this one's one I want you to think about, this is a problem that you know how to do, but it's very different from what you've seen. This indeed is a difference of perfect squares. It doesn't look like it because the number 14 is not a perfect square and the number 6 is not a perfect square. But when we use exponents and I take this x times this x, when I multiply those two things together, I'm adding my exponents. So what I mean by a difference of squares is there's something that I can add to get 14 that's the same number. Meaning if I do like x to the 7th times x to the 7th, even though that seems strange, x to the 7th times x to the 7th is truly x to the 14th. I keep my base and add my exponents. So this is a perfect square. X to the 14th is because I have the same number times itself that's going to get me what I started with. Y to the 6 is in the same boat. 6 is not a perfect square, but 3 plus 3 is going to give me 6. So I can use the same exponent, and that's going to get me what I started with. Put 1 plus and 1 minus. See if you can factor these again, but because they're odd, I cannot. So I'm done. All right, number 10 is just one that I wanted to show you. When you have a very big degree, you're probably going to be able to factor multiple times, right, if it is factorable. So if I look at this problem, I can't do a GCF, but I can start out by saying, hey, this is a difference of perfect squares. Square root of 1 is 1. Now, square root of 16, this is where I'm worried that you're going to put 4 and 4. But if I do x to the 4th times x to the 4th, when I multiply exponents, I actually add them. That would get me x to the 8th. So that's not what I want. I actually want x to the 8th and x to the 8th because when I multiply, I would add to get 16. One of those is a plus, one is a minus. Now, we're not done because this is a difference of perfect squares. I'm going to drop this down to 1 plus x to the 8th. And then I'm going to factor this guy, 1 minus x to the 4th, 1 plus x to the 4th, because that is a difference of perfect squares. I'm just going to erase this to get some room. Then we're going to look again to see if it factors again. Well, 1 minus x to the 4th is a difference of perfect squares. So copy down 1 plus x to the 8th. I can't factor that guy. I'm going to factor this as a difference of squares, but I still have my 1 plus x to the 4th. So 1 minus x to the 4th, square root of 1 is 1, square root of x to the 4th is x squared and x squared. Make 1 a plus and 1 a minus. And yes, I have one more factoring to do. 1 minus x squared is going to factor into 1 plus x and 1 minus x. And then I have the 1 plus x squared, and I have the 1 plus x to the 4th. So this would be my final answer for factoring 1 minus x to the 16th. Okay, look over these notes as you need. Go back. You can rework some of these. And then tomorrow in class, we're going to work on factoring by grouping and combinations.